Welcome to UR Tech Partner, your ultimate destination for mastering AI and DevOps. Dive into the world of cutting-edge technology with us and unlock the secrets of artificial intelligence and development operations. Stay ahead of the curve and elevate your tech skills. Learn AI and DevOps with us today.
Okay, welcome again to another tutorial. So we have seen that how we can create customized Docker. Next step is to push it to a repository so that it is accessible. And for example, it is very easy. You just go to docker.hub.com. Okay, something wrong. hub.docker.com. Sorry, other way around. So that links you to this portal easily. You just have to sign up or sign in. So you could also sign in with the Google. If not, you can go with a very simple process. Then you might be landing on this page. This is your username. This is the complete repositories. One thing which is very important that if you really want to privatize or you want to keep your image file as a private, then you have to buy a subscription. Otherwise, as a public user, any image you customize or any image you create will be visible on the internet, which means public. And if something is public, which means you can also access the Docker Hub as a free account. So this is the thing. So, well, if I go to the command line again here, what we have done so far, we have created some image. Which is totally customized. We have installed something in it, XYZ, whatever. So now we want to actually push this to the Docker Hub, right? First thing first, I need to know my Docker Hub passwords, which I need to retrieve. And after that, I can supply here the command docker login, and then it's gonna give me to that setup. Okay, Docker password याद है इसका भाई यूजर नेम फैसल सोर्स था अकाउंट सेटिंग था fair enough good password and if you go to the account setting you will land on this page. On this page you have the personalized access token where you can create it. So well, great, I have created a new token here which I have copied here. Now what I can do is that I can go to the here like where I have created my custom image here. Now I should actually do like Docker login U. This is my Docker login. The password is my authentication token. Oops, which I should be pasting here. Control Shift V. Oops. So the thing is that might be I have used that token multiple time or something happened here. Connection failed. Okay. So I have to wait a bit until my network connection is restored. because something is not going good. And I'm also connected to kind of public domain, which means that your internet firewall might be hindering you. But yeah, let me just check. Okay, after resetting the connection, let's try it once again. It doesn't work and now Docker. Then we can supply a command login. This is a universal command. You vessel source, and in the password I can give my password and login succeed. As you can see that there was a problem of network, and if ever problem happened to your virtual machine, if it is a Ubuntu base, you can go to the device and network setting. In the network setting, you could always switch to the bridge gateway or the NAT. NAT means that network attached storage, which sometimes support a local area network, which means that you're connected to a big network and network attached storage is accessible to another network. For example, a hard drive or SSD or solid state drive, something like that. And virtual machines sometimes have problem with that via the internet. You can also go to advanced settings, so that's that. But the main thing is that we have covered this. Now, if I supply simply Docker PS, it's going to show me different images. But if I supply Docker images, there we go. So we have this new image. We have created this. Now, as I discussed in the earlier tutorial, that you mostly require to follow the convention of the Docker Hub repository. And Docker Hub repository says that your username / your image name and tag should be coming. So that's pretty much a convention. So here, as you can see, that we have the problem that we have the image, but we need to kind of change this image into the conventions. Let's do it first, and then we'll push Docker simply. And we are right now on the manual approach, and right now we are seeing that how we can create a custom image, installing all the necessary dependencies, and then we can push it to the Docker repositories. When we'll see this, then the very important concept of Docker in the DevOps world is the Dockerfile. And Dockerfile is a more automated way and more clean way, which is widely used by the enterprise level industry. So this is also very important. So let's first rename it, and then we'll see what we can do with that. The command we can use for that is always Docker tag. This is the command. Then the name of the image along with the tag, repository tag, which I want to really rename. And now the rename pattern I need to supply FAISAL, so use it, vessel source, which is my Docker hub name, and then followed by new name. In the new name, I can again my, let's say like that, custom img / imgs version 1. So if I'm gonna rename this, and I again supply a command docker uh, images, docker images. Well, as you can see now that it has created another, let's say like that, duplicate or the symbolic link kind of thing. If you're aware with the symbolic link is very similar that you want to create a symbolic link to something, but it is just a shortcut, not original one. As you can see here, one thing that the image ID, which is universally identifiable token, hash token, remains same for both of the image, where I have changed the tag name and where I haven't changed the tag name. Now, next is that we are good to go. We have naming convention / Docker image in version. So similar in the similar fashion, now we need to give Docker push. Docker push is the command, and then, for example, this thing here, colon version 1 is the command. Login we already have done, and okay, there is a typo. We can again prepare it. Okay, now here you can see that I haven't used my password, and the access token I have used here has insufficient scopes, which means that I should go to the setting and tokens, and there I have to mention that what are the permissions and permission I could grant to pull it from the Linux operating system. So let's do that very quickly. Or otherwise, as alternate, we must need the user password, which I don't have right now because I forgot it. And somehow I'm not able to reset it. So that's the problem. So let's see that if we can, as you can see here, that I can edit my token in here in the scope. I have written public repo read only. So which is really less, I mean, not enough scope. I have changed the scope and I have hit save token. And now let us give another try. Might be this time. That is helpful. Yeah, great. So fair enough. So as you can see that now I'm able to create a manual customized image for Docker. Number one. Secondly, I'm able to retag or need rename it in the convention what's supported by the convention of Docker Hub repository. And third, I was able to push it to the repository and so it's successfully pushed. Now we can always verify that where is my repositories and stuff like that. So it should be somewhere in my Docker repositories somehow, but I'm not able to see it. Da, 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 da. Let me just check Docker admin console, Docker home. Where are the repositories actually? I can also search it in fact, but I never use it from the console. This should be Docker Hub. Well, as you can see that now Vessel source / my custom image. This is the kind of image which we have built right now. This image is built on the Ubuntu machine. Ubuntu is the Linux-based system. We have created a base image. On the base image, we have installed our required dependencies, whatever our software needs. In your organization, if it's big organization, might be your task is always to create a multiple different sort of these multiple you know dependencies and images, multi-stage builds and everything. And after that, you always need to pull. Normally in the organization level, you would see here private because it's on the organization level. As you can see here, I can click on the organization. But for demo purpose or for showcase purpose, we can easily see that this is public image. This is not private. Now I can click here. I can click on the tag. In the tag, I have version number 1, and in the version number 1, I have this uh, identifiable. And if somebody want to pull this Docker, this is the command he needs to supply. Linux-based system, it's saying me. And if I want to go and want to see more layers, so what Docker does always is that it create a layers on top. For example, every single command you supply it, it's going to create a more layers. And here I can see that it's supplying a continuous command, which make this operation always alive. On the bash level, the Ubuntu version of the image, I label open container in the 24.0 and a lot of other, a lot of other information we got here. So that's that. So the description, we should always give a description of your image, and here I could see that a test custom image pushed PUS HTTP pushed from Docker virtual machine, right? So that's that. That remains same. And down the line, the agenda is that we have done all this part. So we have seen that there are two major approaches to create a custom Docker images, and one is the manual approach. The manual approach is still in use in a way that you need to test and trial something. For example, you need to install something and you need to always see that what my command is doing, what my software installation is doing. In that scenario, you could easily test and trial with the interactive mode, and might be you need a manual approach where you test and trial different steps, and if you're happy, then you do Docker commit, and in the end, if you do Docker commit, and then you can push your image manually. So this is the approach number one. Now, the second approach, which is actually mostly adopted in the industry and very important in the DevOps world, is automatic approach. And the part and parcel or nut and bits are a very important step to carry out when you're creating any automatic approach for the Docker custom image creation. You always have to work with Docker files. What does Dockerfiles means? The Dockerfiles means that it is simple a file which gives a declarative commands of the Docker created by Docker. This language, this is not language, you can say. It is very easy. The good thing about Dockerfile is that it don't use any language. It don't use any YAML. It doesn't use any Groovy syntax. It doesn't, as we have seen in the Jenkins, that you always have to write your Jenkins file in the Groovy syntax, which is kind of a new language you have to learn, or JSON and XML or YAML. Might be you have seen much of the YAML in the machine learning and data science world that you have to always deal with. But the good thing about Docker, you don't have to worry about the language syntax. It is just text, and you always start your text file from the from, and it automatically gives the declaration. So we'll see in detail. We are going to create a custom image. We are going to create an image where we actually need to install Nginx and port forwarding and port mapping. So virtual computer doesn't actually allow any traffic to the network, which essentially means that we always have to map or forward the port from the virtual machine to the Docker machine, which this concept of networking we have seen already. So yeah, that's pretty much it. And then let's see how Dockerfile works. Let me give you a scenario in your organization. Your team has, or your team head or manager says that, well, we are going to create a new Docker image which essentially needs to have Nginx. Nginx, as you know, is a server which runs websites, Java-based websites, and we need to install it, and then we have to make it available to the pre-prod environment or development environment for the test and trial for the internees. Internees have some application they're working on, and they really want to check that well in the development environment that works or not. So that could be a one scenario right here. So yeah, uh, that's that. Okay. Now do automatic setup, and in automatic setup, what we need to do is that we simply create a new Docker file, which we can do by touch. Dockerfile. The name is optional. You can barely name anything. And as you can see, we have Dockerfile. We can say nano Dockerfile, which ends up similar to that. Then we copy paste some material here, which is kind of self-explanatory here. For example, these were not required actually. If we say here, here. So now let's briefly discuss that what does mean by this run command. The run command is nothing but a declarative. Whatever you see here in the capital letter, like run, from, cmd, entry point, copy, any module. This module is normally a command line or command declarative which you give to the Docker. That Docker recognize that whatever in capital letter, and this is from run cmd expose. These are the module written by the Docker. This is language. So what you see in the CMD, it is very necessary. It depends on the software. For example, if you're using Java-based application, you need to write this user bin nginx, or if you are configuring the nginx. So for example, here we are trying to configure a nginx server. Nginx is a very well famous web server for the website and web-based application to run on, and it's normally run on the port 80s. And now what we are doing pretty much similar stuff, that we are giving an instruction to our Docker that from Ubuntu, please get the image from the Ubuntu, the bare image or base image or minimum skeleton, then please go and install update. Then please install Nginx and Vim on it, and then please make a directory and create a configuration directory in it, and then please create db.props, and these are automatically filled when the Nginx server is running. And then in fact, we come down here and we'll see that everything good, everything looks good, right? And then what we can do is that we can say docker build, and yeah, that's pretty much it. And where we want to save it. So if I really exit, Control X, yes, I want to save it. And now if I clsdr with command Dockerfile, and it has, I can echo my Dockerfile. 9. If I can get my Dockerfile here, and I can see that there is some information in it. And now the command to run it is the docker build build. Then, for example, name of my file is Dockerfile here. Docker build Dockerfile. The tag is, for example, the tag I can give already Faisal source, my new dash or slash image dash version 2. I can say it a version 2, right? And where I want to do it, the current directory. And right, so well, uh, my Docker file. Okay. It's an internal directory, which means that it should. What we are missing here is that Docker build file of Docker. Okay. Unknown instruction X, where I have given the X actually nano Dockerfile, and there is one typo here, just said. So that happens sometime. Okay. There was maybe indentation issue. It failed. Okay, the major problem was here that we have here the typo in the update, which is really very bad. We shouldn't have such a typo in this Docker file. If there is any kind of typo in the Docker file, then it's not going to run. Now we have run version 2 of it, and it should take some time. It's going to install Nginx. Whatever you write in this setup, whatever it is, regardless, whatever you can actually write on the Linux, any command, any sort of thing, it could be doable on the Docker file as well. You can give it any kind of process, any kind of steps to follow. As we can see that Docker images, if we write here, and here version 2, new image is already done. This is 195 MB. If I want, I can Docker pull it, and it's going to do the trick. So that's how you really manage this. So as you can see, we have covered a lot of stuff right now. We have seen that how you can create a Docker file. Well, then there is one important concept, which is that I have run, for example, here CMD, right? And if I want to run Docker run IT and vessel source slash my new img and then v2, so in bash. Well, I'm able to go into the interactive file. I just normally get out of the Docker with pq docker ps. Yes, great. As you can see here that this image actually the command is now occupied by bash, which is mean that it has assigned again a new bash process command to it, which is sometimes not needed or which is sometimes not very good because otherwise your existing process, which is very essential to run Nginx server, your command is overtaken because I have run this interactive or I have tried to I have tried to run this Docker in the interactive mode. So sometimes you need to hinder this, or sometimes you need to block that item. So if you need to block this, then you need to write entry point rather than command. For example, nano Dockerfile, and here rather than cmd in the capital letter, you write simply entry point here, and then you can just save it and overwrite it. And now if I create Docker build again, because this changes hasn't been, done, because I need to create it again. So now if I say version 3 to my tag, and the Docker context or any artifacts you need to copy, or whatever is written in your Docker file, sometimes you write that copy some item from place A to place B. So these are the context item, and you must mention the folder of context item which needs to copy. For example, I just write copy something from my virtual machine to the end source. Then if I say dot here, which means that my file which is need to be copied from the virtual machine should be present here in this file, and this is called context. So this dot mean context. Otherwise, if my file is somewhere on user, for example, I say that my file is on user share and then HTML or something like that, I have to give this, right? And I don't have any other artifacts, and that's why I give this. And this, now you can see that I have created a file which is on entry point. Yeah, right. And now if I want to Docker run interactive, then, well, just a moment. Okay, so as you can see now that we have changed this. So now we have written Docker. Now if I write here that, for example, let me just write uh, Docker interactive in the bash mode. As you can see that it doesn't return me anything back, which essentially means that it's not going to return me my command prompt, and it's hinder me. Why? Because now I have written entry point rather than CMD. If I would write CMD, it should overwrite automatically bash process in such case. And sometimes you need that because Nginx server essentially needs to run this process in the background to make services available on the website, on the browser, and you don't want it. That's why you need to write entry point in your Docker file rather than to write CMD. And now if I just exit it, and or I cancel it and I say Docker PS, and here you can see that this process with tag version 3 is occupied by this process and locked itself, and this won't allow you to come into the Docker interactive mode and do something with Docker, which essentially means that all other two Docker, which are version 2 in our case, already overtaken the process, even though we write this process to be run. So this is actually a very important command, and it is sometime also appear in the interviews of the DevOps that what is difference between entry point and what is difference between CMD. So CMD and entry point pretty much does a similar function, but the only thing it does that it prohibits interactive use of the container. And why it do so because if you sometime need to go and change something, then this process is automatically overtaken, which means your container is not, even if it is running, but it is not able to give you a services of your Nginx web server on the port 80 TCP. So that is actually fundamental right now difference, and yeah, that's pretty much it. And here now, by now we have covered this concept as well. That so what is actually difference between the the interactive mode with this there's two things, entry point and CMD. We have covered everything by now. The only piece of puzzle is needed, that where does Docker comes into the picture in the whole life cycle of the DevOps software lifecycle development. So it is very simple. Let us draw something. So for example, I have a multiple environment. I have a development environment. Then I have a higher environment, which is pre-prod. Then maybe I have something production environment, right? And now we have seen in the tutorial number 1 that how containers solve many different issues of server code mapping and how efficient it is and how fast it is. We have seen by now that you can just with couple of lines you can easily create as number of as container you can, and they're available and everybody see the same result. It is not that you're using something on laptop and it's giving you different result, different dependencies, different software version, blah blah blah. That's why you call it container, because it containerize itself and make that application available across the globe very similar fashion in exact similar way and doesn't change anything. So if we talk about right here the process is very simple. You have code of your thickness is little bit increase. I could do that. So for example, you have environment where you have very simple code written somewhere. You write that code. Here is the code written somewhere. Great. This code run through CI/CD pipeline. Why CI/CD? Because it automatically checks that code stages, which means automatically do some stuff like it review the code, it tests the code, it automate the code, like code review, code test, code coverage, unit root test, or whatever you need. Test code review and a lot of different things is done in typo. This code is according to the standard of the code writing process and whatever. In the end, it gives you the package here. It gives you the package. What is the package? After this code pipeline automatically does, for example, you have Git here. You have written this code on the Git. There is hook involved here. This hook automatically trigger the Jenkins pipeline. This is here Jenkins, right? This is Jenkins here. This automatically trigger your pipelines and give you PSC packages. It gives you in the end a package, which is in our case sample.var in case of Java base app, sample.var. So you have created a application. In Python case, it could be different and whatever. Now what you need to do is you need to, for example, deploy this application from CI/CD. Might be you have some configuration on the server, and you can do this by Ansible. And for example, you need to create this three environment here. For that, to create a three environment, you might be need in the next step, for example, down the line, infrastructure as a code, which is IAS, and Terraform, Terraform would do the trick. Terraform, and then Ansible would do the trick. These are for server configuration management, and this is for server creation. If you don't know about this tool, you can go back to my tutorial and see that what they are. And after your code has been packaged, you're good to uh, throw this to dev environment. For example, some internees are trying to check and test and trial in the dev, and this is pre-prod server or pre-prod environment, and this is final production PROD. This is our final production environment. They are all linked together, or on some level they are linked in the hierarchy down the line. Sample var the app actually is similarly going there. Similarly, same copy going there, and same copy would be going here in that environment, which essentially means that you have some Docker running it on it. So, for example, I have one Docker here. This is Docker container where Nginx is running, and it is now very easy that I create a I'll need a Docker file here. Here I need to run, for example, different dependencies. What could these dependencies could be? This could be, for example, Java, number one. Then it comes to JDK, and then, for example, Nginx, or in this case, Tomcat, let's say like that, because Java running on the Tomcat server rather than Nginx. Nginx is for web server for other technologies, and some other configuration you need to do. What you do, you write a Docker file here. You just simply write one single Docker file in which you write something. This Docker file, you Docker build something, pull to registry on each of these Docker. What you do is that you just run this Docker file once from the Docker hub. This file, create something, some artifact, push it to the push it to the push it to the Docker hub. Actually, this is for example over Docker hub. This is for example Docker hub hub.docker, and from hub.docker you get exact same three file here, here, and here in all those three servers, and they look exactly similar without any problem, and you can run your application without any problem. Now, for example, down this stack, if you need to change something, for example, you have to do nothing. Why? Because mostly a developer has to do something. Why? Because you have already done your part, and when developer need to change something, he comes here and he writes something or change something on the Git. Let me just change my pen color, and here actually developer change something. For example, here he changes something, and very easily what happens is he writes something, he changed something, and it automatically get picked by the Jenkins pipeline. it do complete process down the line. Then it create a sample var.app here, and then it's automatically throw it uh, to the it automatically what it does, it actually automatically upload here. So the final in our Jenkins pipeline, we have here automatic pipeline which write the Docker file here and which actually creates this Docker file. It automatically build a new Docker file, and in new Docker file we have written that please pull something from here, please pull something from here, and it automatically pull. Here is automatically pull, here is automatically pull too. And in this fashion, you barely have to do anything. You don't have to do anything as a DevOps engineer. You are responsible to create this automation here from the code to the user interface where actually a user can see something very beautiful, a web page or interface here down the line. And whatever changes here, doesn't matter what, is always actually showing up in this address bar. That's actually complete the life cycle process of this from writing a code as a developer, getting it to review and packaging it, and deploying it to the. So normally all this process, this much stuff here that belongs to AWS or any cloud normally. So you need to know the cloud. For the cloud, we need the Terraform to create these infrastructures. You don't have to go in the cloud and you click on the, for example, you don't have to click somewhere and create these resources. For example, this could be a EC2 instance, EC2, or this could be a Fargate, Lambda Fargate, or of AWS, or this could be a serverless computing, same serverless computing module. So this could be any, or this could be maybe Azure, Microsoft Azure. This could be also Microsoft Azure, any cloud you like, you're here. And very easily it's deploying in all these three server. And in the end, user would see here and effect. So that is pretty much the whole life cycle. But let me just tell you that this is just beginning. And well, Docker is very important, that is for sure. But normally down the line, there are many different stuff. When your application get complex and complex and complex, you need Kubernetes K8 clusters. And that is our next topics, Kubernetes. Kubernetes, and we'll see down the line how Kubernetes is Google server. They have created this to manage this Docker, and that really revolutionized the world. And now everyone in the industry is using that because it's efficient. It's handled a lot of security automatically. It's handled the storage automatically. You can manage like thousands of container automatically. For example, this container get destroyed within the millisecond. Kubernetes would place another duplicate beautiful container so that your application won't be hurt. So yeah, that's the pretty much about Docker. So some topic we might not discuss is that there are some other topic in the Docker. So whatever Kubernetes give you a solution, you can also do with Docker Swarm. So let me just write you some topic like Docker storage is a one topic, Docker Swarm, Docker Compose, and Docker security. So these are the topics that by default Docker also offers, and it offers historically when there was not Kubernetes in the market. Then Google come up with some solutions. They said that these solutions are very outdated and they need to improve. Then come up very beautiful tool which is free of cost and open source, and that is actually Kubernetes. And then nowadays, all the industry, 95% of the cases, they are using Kubernetes to manage the Docker. You must understand Docker in detail. That much concept is important for you, but in the Otherwise, it's not. These topics are not very much important if you are planning to learn Kubernetes. Thank you very much for watching. If you think that adds some values to your knowledge, please hit the subscribe and like button and see you next time. Until then, bye.